It might be a short bit in here, but are there any questions?
How do you integrate with respect to meters per second to the 3 halves? How do you treat that unit?
All right, the constants keep their units. So if I've got 4 meters per second to the 3 halves times the square root of time. Ultimately, if time is in seconds, this becomes meters per second to the 3 halves times seconds to the 1/2, which is just meters per second. So in terms of integrating, that is a constant. So I prefer the fractional exponent when I'm doing integration. So this basically it's 4t to the 1/2. If I integrate with respect to time, I add 1 to the exponent, and then I divide by that exponent, which was a mistake that a number of people made of multiplying by 3 halves instead of, multiplying, I guess you divided by, that's my mistake right there.
You divide.
You divide by 3 halves.
Yeah, so, but you gotta multiply, you're really multiplying it by 2/3, right?
Yeah, so that's 8/3 t to the 3 halves. Now, the units here are associated with the 4, and that hasn't gone away. This 3 halves is unitless. So this becomes 8/3 meters per second to the 3 halves, t to the 3 halves. If you could double check yourself, if time is in seconds, well, the seconds cancel out, and I'm left with meters. This was meters per second, so it's like a velocity or a speed. If I integrate that, I should be getting some sort of distance. Meters works.
Okay.
Oh, yeah,
Oh, so you're saying the time and the seconds cancel?
yeah.
Yeah, this has to be a fractional exponent, because
So
that's gonna
because
be
that becomes a fractional exponent too?
yes.
Okay, that makes sense, thank you.
Yep.
All right.
Oh, I definitely did that wrong.
You were not the only one.
Okay.
Yeah, the most common mistake here is instead of dividing by 3 halves, you multiply by 3 halves. Saw that too many times.
Ah,
And it could have just been, like I did just then, where it was a small little burp. Or it could have just been the alignment of the stars. Other questions?
Can we turn in our lab?
Pardon?
Can we turn in our lab?
Yes. You don't need to ask. I tend not to ask for, hey, time to turn things in. I'm assuming people will turn them in when it is time.
it's not really due till midnight tonight, right?
Yeah.
So that's why I got a couple questions answered. So it shouldn't be too bad.
Pardon?
I don't think I have much left, so it shouldn't be like midnight on the dot when I turn it in.
Well,
Maybe like 6 o'clock.
if it's due at midnight, I'm not gonna wait until tomorrow morning. Or I'll be up at midnight, check it. Ooh, it's not in yet. It came in at 12:01. I apologize if I've mentioned this before, but when I was working with IT consulting, every project went late. This whole idea of you gotta turn things in on time because that's what it's like in the real world. But my experience was every project's late.
That makes me feel less bad.
Feel less bad.
However, ultimately, there is a deadline, and if you don't do what you're supposed to do, you get fired.
Yeah.
So it depends on how much we really want to model the real world. I'm sorry, your performance is that inadequate? Go find another class.
No refund on nothing. Just go.
Any other questions?
For the graphs, can those be like on the Excel spreadsheet, or does it have to be like on a separate document submitted with the?
It can be on the Excel spreadsheet, just not hidden. There are sometimes people will, you know, you got the numbers right here that you're dealing with, and then the graph is over here off screen, and I don't think to go scrolling into the infinity.
I mean, like, mine are next to the numbers.
Okay, that's
Perfectly fine, right?
it's, if I can find it easily, or you tell me where to find it, okay.
There's like a space here, right?
All right. I'm gonna do a little bit of prologue for today's lab. I've already gone through the math last time, but I do want to comment. This probably is the last one where you're dealing with uncertainties, so, but it is the most brutal. However, there is a document, a PDF, that's posted near the labs, which goes through an example. And it's written in there, it's sort of scrawled in there as opposed to typed. But on page 4 here, where you have A, B, and C, I'm assuming at some point you, when you're trying to find the time in the air, you're gonna be dealing with a quadratic. So I'm assuming AT, you'll have an equation, AT squared plus BT plus C equals 0. And that is the reference to A, B, and C. So what I am expecting here is whatever your value of A is, plus or minus whatever the uncertainty is. And the reason I have this whole section here is this is keeping track as you go. Because in an earlier version of this was not here at all, and it was really difficult to figure out how students got some of their answers. And so this is to help me troubleshoot where the problems are. That's the purpose of it. And again, I want to emphasize, because not everyone read this apparently in the past, there are, let's see. Yeah. So there's 4 things underneath this line right here. For the next 4, if you realize which will not give the correct answer, then skip that calculation. So you got 2 of them without, that are not fractions, and 2 that are fractions. So one of those 2, it might be obvious as you look at it, it's gonna give me a negative time. I'm not gonna worry about that. So if you can identify it conceptually, which of the first 2, and which of the last 2 will not give you an answer, then you don't have to fill it in. Any questions before we go and actually see equipment? Now that Zachary's here and winded, let's move.
Sit from the stairs.
Excuse me.